Well, good evening. Welcome to Space Oddities. Thank you for joining us on this Tuesday. Hope you're all not too hot wherever you are. So this evening, we are doing a bit of a retrospective on the Gemini 10 space mission, which is celebrating its 60th anniversary. It was a very important and innovative space mission, which paved the way eventually for the Apollo moon landings. So that's what we're going to have a look at. So apart from that, we've got the usual stuff tonight. So let's kick off by going straight over to Michael. And Michael, tell us all about the Gemini 10 mission and its 60th anniversary.
Okay. Right. Let me... Hold on.
You
okay? Can you see? You got my screen? Yeah. Okay. This is all about Gemini 10, 3 days that changed spaceflight. In July 1966, as part of the NASA Gemini program, astronauts John Young and Mike Collins spent 3 days in space with Gemini 10, achieving the first rendezvous with 2 spacecraft, the first 2 spacewalks in 1 mission, and a new human altitude record. This is the Gemini spacecraft. You can see it's a very cramped capsule with just enough space for 2 people. So Gemini 10 was designed to achieve rendezvous and docking with an Agena target vehicle, or ATV, and do EVAs. It was also planned to dock with the ATV from the Gemini 8 mission. Okay, this is the crew, an unlikely pair of John Young and Mike Collins. John Young, a reserved Navy test pilot, methodical, unshakable. Mike Collins, gregarious Air Force fighter pilot, witty and fearless. Different in every way, united by the mission. Okay, John Young on the left, Mike Collins on the right. Okay. The Agena launched on top of an Atlas rocket on the afternoon of July the 18th, 1966. Gemini 10 followed just 101 minutes later, climbing into the blue sky on a Titan II launch vehicle. Okay, this is a picture of the Agena target vehicle, which the Gemini spacecraft was to rendezvous and docked with. And this is a photo, one of the few photos I've found from the mission, which shows it from the Gemini capsule. Finding another spacecraft in the vast darkness of orbit is a prerequisite for Apollo. Locking two vehicles together in space, the core skill for lunar landing and return. Gemini 10 had to prove both can be done, not once but twice, before Apollo risked it all on the moon. And this is the a photograph of the docked capsule with the Agena target vehicle. Once docked, the Agena target vehicle, the crew instructed the Agena target vehicle to light its engines, and it raised the Gemini 10's apogee to 474 miles, higher than any previous crewed mission. From there, John Young and Mike Collins could clearly see the Earth's curvature. On 19th of July, Collins opened the hatch for a 49-minute stand-up spacewalk. Standing on his seat, he marveled, the stars were everywhere, he later wrote in his book, Carrying the Fire. Above me, on all sides, and even below me, somewhat bright and steady. Sadly, no imagery exists for this event, as 4 Hasselblad cameras didn't work, and 1 even floated away. This photo is actually from a similar event from Apollo 9. So once the first Agena was succeeded, they undocked from the first Agena and then chased went to find the Agena from the Gemini 8 mission. The Agena from Gemini 8 had gone dark months earlier. No radar beacon, no running lights. Young and Collins navigate to it using raw observation and piloting skill alone. triumph of human judgment over technology, exactly the kind of skill that Apollo would demand. An historic first, 2 EVAs in one mission. Gemini, the first mission, was the first mission in history to do 2 separate spacewalks, pushing the absolute limits of life support and pressure suit capability. Again, these are images from other Gemini missions, as there's no photos from Gemini 10. Once they found the Gemini Agena vehicle, Collins floated across the dormant Agena vehicle and retrieved a micrometeorite detector. Humanity's first hands-on contact with a separate orbiting spacecraft. As Collins began a planned activity to further test the handheld maneuvering unit, he noted that while retrieving the micrometeorite experiment and moving to and from the Agena, he inadvertently lost his Hasselblad camera. To date, this is the only spacewalk not captured with photographs. And this photo I have here is Mike Collins during training for that task. So 3 days later, splashdown, precise landing in the Atlantic Ocean, just 3.3 miles from the target and from target within sight of USS Guadalcanal. And the actual crew of the Guadalcanal will actually watch the capsule come through the clouds and splash down in the ocean. So, legacy from Gemini 10. Both men went to the moon. The Gemini program was, of course, a vital step towards landing on the moon. But John Young, although already flown on Gemini 3, John Young went on to fly on Apollo 10 and Apollo 16 and the first flight of the space shuttle STS-1. It was also the spacecraft commander for STS-9. Mike Collins orbited the moon as Apollo 11 command module pilot, while Armstrong and Aldrin made the history below. Okay, and that's it. Just a quick recap there of that then. So, okay. Right, let me stop sharing. Hold on it. Oh, are you on mute? You on mute, Andy?
Yeah.
So, because it also, I mean, it was the first time that once they had docked with the Agena, that they used the Agena engine to put them into a higher orbit.
That's right, yeah.
So they fired the Agena engine and it pushed them up into a higher orbit. As you said, they recovered the meteorite sample panel thing. But also, they fired the Agena engines twice. The second time to put them into a higher orbit so they could rendezvous with Agena 8.
Yeah,
which of course was the Agena that gave Neil Armstrong problems when they docked with it. When thruster stayed open and they went into a wild spin. And the mission was nearly lost if it wasn't for the skill of Neil Armstrong himself saving it. But it was a very interesting mission because, like you say, the main point was the meeting up of different objects in space, because that's what the Apollo was all about. The rendezvousing, to make sure you could find the things, because they did have problems with meeting up with their Agena, because didn't the batteries fail, and so the Agena had no lights. It was only by reflection of the sun or something that they were able to see it.
The Agena from Gemini 8 didn't have any lights at all. So, I'm not sure about the Agena for Gemini 10. But you got to think about the timing for the launches as well, because the Agena was launched first, and just 101 minutes later, the Gemini was launched. You know,
Yeah, because if I remember right, during the Gemini, one of the Agenas was actually lost.
right.
But they still took off. I can't remember what numbers it was. The capsule launched anyway, because at the time there was also a capsule that had launched a few days earlier,
That's right.
and
Yes,
and yeah, and they decided that they were going to rendezvous with the capsules.
that's it.
And there's images of them circling each other, and you could see the astronauts in each capsule as they moved around each other. So they still did the rendezvousing, but they didn't do
Yeah,
any joining and stuff
right,
like
yeah,
that. So,
yeah.
I mean, these were the missions that basically, I mean, you're talking about, you go back to Mercury before that, the Gemini, they were essential, and they were essential to work for the Apollo to work, because they were sort of like the basis that everything else moved on to. But because of course the actual Apollo space rocket hadn't actually been built in, well, it was in the process of being built.
Yeah.
So yes, it's it was these whole series, and people tend to forget how important the Mercury and the Gemini missions were as a stepping stone up to the actual moon landing.
Yeah, I think majority of the general public would know about Apollo, but would know about Mercury and Gemini is another thing.
Yeah.
I think, you know.
That's right.
So yeah.
Okay, well, thank you very much for that, Michael. And happy 60th birthday, Gemini 10. Can't believe it's 60 years for those of us that remember these things actually happening. But there you are. All right, we're going to move on now and look at the week's news. Now, there have been quite a few interesting things happening this week. Firstly, big congratulations to China. Because of their achievement this week. What did China achieve this week? Well, in the era of reusable rockets pioneered by SpaceX, very few companies or organizations have been following suit. But China have been working on reusing their first stage boosters for their Long March rockets for a long time now. And this week they actually managed to do a controlled landing of the first stage of a Long March 10 rocket. And let's just have a look at this, because it's really, really a great achievement. So this was the Long March 10. So they actually managed to capture the rocket using a sort of a net system.
Yeah, I didn't know that.
Brilliant that was.
Yeah. And rather than have a powered landing all the way down, they caught it in what's basically a net. Let's just have a look at those nets in a bit more detail. I swear I used to go fishing with nets like this.
Keep nets.
Yeah, keep nets. But those are the nets that the Chinese used to catch the rocket. And well done, China, the second nation to use reusable rockets. So that's a step forward for the whole of the space industry, of course, because the more competition there is, the more prices will come down. So
it's a novel idea of actually catching them. But also, did you see, Andy, I think it was over yesterday or the day before, they've also been able to partially launch their version of Starship. They got it to launch, hover, and then they've also got that to land safely as well.
Were you talking about Japan rather than China?
Oh, am I? Oh, okay, then I do apologize. Yeah, it was,
Yes, that's what you were talking about, I think.
yeah, sorry, sorry.
Yeah, so this was Japan saying, yeah, we can do stuff like that too, you know. So this was their first launch and landing. So looks like Japan will be joining the reusable rockets team very soon as well. So this is all fantastic news for transportation into space, for getting things into orbit, because when the space shuttle flew, there was something. It was something like $27,000 a kilogram to get a kilo of mass into space. And with the advent of reusable rockets, it's just going to come down to a handful of dollars ultimately. So this is great news for any country wanting to put things into orbit. Okay, well, let's carry on with the rest of the news.
Andy,
just
as a matter of a thought, although it is just a thought, was the Chinese rocket designed by George Stephenson? Because it looks like there's sort of smoke coming out the top, and of course George Stephenson's first train was called the Rocket.
That's right.
Yeah, that's true. That's true. I did wonder why there was smoke coming out of the top of the rocket.
It's steam powered. It's steam powered, isn't it?
It's not.
Steam. Also, I think we need to give some credit to the captain and crew of that vessel that caught the Chinese booster, because if that didn't work out, they really didn't have any place to go. So,
but you didn't see beforehand how they were zigzagging, left a bit, left it. Oh, here it comes. Right a bit.
I mean, SpaceX had a similar thing, didn't they, when they were trying to catch the fairings of the Falcon 9 in huge nets on that boat.
Yeah.
And although they had some successes with it, they stopped it because they considered it too dangerous for the crew. Because if one of those fairings falls on your head, you know about it.
And then they have a helicopter that had some big sort of like antenna that come out the front, and it was supposed to scoop up the parachutes.
Oh no,
was that somebody else, wasn't it?
Yeah,
those are some of the sample return missions.
They'd scoop them up and rather than actually land in the sea or anything.
Yeah, absolutely.
Some ingenious ideas.
Yeah, well, humans are ultimately incredibly resourceful. So there we are.
Yeah, well, and the one thing about the China system is they don't need landing legs.
No, that's right. They don't need landing legs, so less mass. Okay, well, let's move on with the other items in the news this week. Firstly, you know what this is, of course. This is the ELT, Europe's extremely large telescope in the Atacama Desert in Chile, under construction, expected to be ready in about 2 years, all being well. And this week it made a big step forward. They rotated this enormous structure housing the telescope a full revolution for the first time. And this showing here, what you see here at the bottom is the mirror cell where the mirror will go, the main mirror, and then you've got the secondary mirror assembly there. This can be rotated by hand, and it weighs, at the moment, this whole assembly weighs about 360 tons, and it can be rotated by just pushing it around with your finger.
Although it takes about 3 years to accelerate to.
Yeah, well, that's
but yes.
There's always one naysayer, isn't there? So this can be pushed around with your finger, and because it's the whole assembly sits on a thin layer of oil, and with virtually no friction. So they rotated it some of the way manually, and then they wanted obviously to test the actual motors, although they were having a lot of fun, obviously, like kids on a merry-go-round. They moved the rest of it using the servo motors, and everything went to plan. So this was fantastic news. And just to give you, in case you hadn't seen the people in this image, just to give you an idea of the scale. You can see the actual size of this observatory, the world's biggest optical telescope. Can't wait until it sees first light in a couple of years.
Wow.
But things are progressing well in Chile. You'll be glad to know.
So Andy, as we get bigger and bigger telescopes, we had the Lowell Observatory, we had the Hale Reflector, we have bigger and bigger, and now we have this, the extremely large telescope. What happens when we have far bigger telescopes? What do they call this thing?
Well, I mean, there was
extremely little telescope.
I mean, there was originally the 30-meter telescope.
Yes, that's right.
Was going to be called the OWL.
The OWL, yes.
Which stands for Overwhelmingly Large Telescope.
Someday these overwhelmingly large telescopes are going to be overwhelmingly small by comparison. I wonder what we call them. That's my point. Okay.
So anyway, good news from the ELT. Moving on, we're now going to talk about the. Do you remember a few years ago that Hubble made tentative discoveries of what possibly were plumes of water vapor on Europa? This was in 2014. So a paper showed that Hubble had spotted plumes of water vapor on Europa. But 12 years later, the same researchers, using data from the same observatory, have revisited the data, and now they don't think that's what.
You're breaking up on this end, Andy. I can't hear you.
Statistical
we've lost
noise
you, Andy.
as significant. They said the discrepancy with early results arises primarily from differences in the assumed position of Europa's disk on the detector. We find evidence to support a persistent hydrogen exosphere at Europa, but there's no evidence of localized water vapor. So that's a bit of a blow, really. But of course, we'll know there when the two spacecraft get there, Europa Clipper and JUICE.
Europa Clipper.
Yeah, and JUICE. Don't forget JUICE. So we will know more then whether plumes of water vapor do come up from the supposed underground ocean on Europa. So. And there is the image that they were talking about. This is the 2014 Hubble image. If you look at the sort of 7 o'clock position, you can see there that what looks like plumes coming out of Europa, but they now say it was probably just noise.
It sure looks above the noise if you look at the majority of the rest of the image.
Yeah. I'm not going to argue with them. Presumably they know what they're talking about. So there we are. Okay, if you thought Starlink was bad for astronomers, you ain't seen nothing yet, because this week the FCC gave approval, that's the Federal Communications Commission in the US, to a company called Reflect Orbital, and they've given them permission to test in orbit an orbiting mirror designed to redirect sunlight onto the Earth after dark. So they're planning to launch a prototype satellite called Earendel-1 into low Earth orbit. It's going to deploy an 18-meter wide reflective film and attempt to illuminate selected areas on the ground. They say that a future system could light regions roughly 5 kilometers across, producing illuminations several times brighter than a full moon. Possible applications include lighting disaster zones, supporting search and rescue operations, extending agricultural or industrial working hours, and providing illumination in remote areas. They envisage eventually a constellation of, get this, 50,000 mirror satellites. However, this hasn't gone down well with the astronomical community. a European Southern Observatory study warned that a complete constellation could severely disrupt astronomical imaging, potentially ruining every exposure taken by survey telescopes like the Vera Rubin telescope. They say its mirrors would normally remain inactive, whatever that's meant to mean, and could avoid observatories, but campaigners are calling for fuller environmental system and public oversight before such a system is deployed. So that is just appalling news. I'm amazed that the FCC have given them permission to launch a test satellite. But
and of course, what we need is more sunlight on the Earth to help with global warming.
Exactly.
Absolutely, it's exactly what we need.
That too.
Yeah. So that's a real blow.
Sheer madness.
Yeah. Moving out to Mars now. Congratulations on the Perseverance rover, because it's completed a marathon on Mars, 26.2 miles, or if you like, 42.195 kilometers, since landing in Jezero crater in 2021. And it passed the marathon milestone on June the 14th during the 1,890th Martian day of its mission. It covered the distance in 5 years and 4 months, considerably faster than the Opportunity rover, which required more than 11 years to travel the same distance. And a day before the milestone, the Mars Reconnaissance Orbiter photographed Perseverance. You can see it inside that box there. And you can see the wheel tracks around it as well. Very clear image from the MRO. Perseverance is currently exploring a region west of Jezero crater that the mission team has named Arbot. Throughout its journey, the rovers examine Martian geology, search for evidence of ancient microbial environments, and collecting rock samples intended for possible return to the Earth by a future mission. And of course, this demonstrates both the rover's durability and the increasingly ambitious distances being covered by rovers on Mars. So many congratulations to NASA and JPL for this marathon achievement.
Yeah, I think that finishing time will be the same as me running the London Marathon. There's pubs on the way. That's right. There's pubs on the route. That's right.
I don't think I would ever finish it, to be honest. You may remember, viewers, that a few weeks ago we had Melissa Quinn as our special guest from Maritime Launch Services, and she is helping to build the Nova.
Oh, he's gone again.
Because the Nova Scotia Spaceport has reached a deal with a German launch company called ISAR Aerospace, $50 million.
Yeah, we're definitely losing Andy here.
I wonder if we might want to move on and give Andy a chance to debug this, or perhaps log out and log back in.
Well, he doesn't. Let's have a look then. Let's see what we can do. Yeah, basically, as Andy was saying, that this company, it's a German company, have actually formed a contract with the Nova Scotia launch pad to basically launch several hundred rockets from there. So, of course, as we said, we had Melissa on the other day, and they were moving on pretty fast. I mean, they've already launched also some sounding rockets over the last week or two. So it's been very good news for them. And all more power to their orbit. Let's hope that they can get this up and running soon, because the more launch sites that people have got, it gives them more variety of access to different orbits and things like that. So
yeah, absolutely.
So are you back, Andy?
Can you hear me okay? I think
we can hear you now. Yeah.
Right, just give me 1 second. I just need to adjust a few things for my sound. I'll be with you. Just talk amongst yourselves for 1 second. I think I know how to solve it.
Okay. Yeah, and we lost Lou, but Lou is back.
He's back in the room.
You never really lose me. You wish you had. Sometimes you wish.
There was a glitch in the matrix. So yeah, it's been quite an interesting week, to be quite honest. There's been a few stories about, but that one about the mirrors, it's madness, absolute madness.
Yeah.
I mean,
well, you'd think the health community as well. I mean, they've known now for decades how bad all this extra light is at night for people's health. I mean, it's really way more debilitating, I think, than
not to
anyone
mention
realized.
wildlife.
This
Wildlife.
and what
some surveys show dramatic increases in breast and prostate cancer as a result. Light enters the optic nerve, that influences chemistry in the brain, and these are both hormonal.
Yeah, no, I mean, depression, and there's just so many things associated with that.
Yeah, absolutely. That's interesting.
Yeah, depressed astronomers, even worse.
Okay, I've got a few technical buglets here, so I think we'll make. I'm just coming up for the last item anyway, so I think we'll knock that on the head for now. So, apologies for that, viewers, but this is the as Derek correctly says, this is the joy of live broadcasting. You never know what's going to happen. So, so there we are. Right, we're going to move on now. And we're going to move over to Lou now, who wants to tell us all about a new book, I believe.
Yeah, thanks. I should be able to bring it up over there, Andy.
Sure.
I really had fun with this. I mean, I enjoy doing the science. There's a little science in here, right? But this was such great fun. And it's about a book that I really enjoyed. The book is called Colony to Mars. It's by Gerald, I guess, Kilby. And it's a pretty gripping second installment in the Colony Mars science fiction series. There's a Colony 1, Colony 2, Colony 3. I didn't know that when I picked Colony 2, but I'm going to go back and read Colony 1 and the other. So basically, the book follows Dr. Jan Malbec. She's the lone survivor of an ill-fated mission to Mars, and she's abandoned on Mars and designated a biohazard by Earth. There's a pathogen floating around. I think it's killed a few astronauts, and there's no cure at present. So she discovers a supposedly dead colonist. She thinks she's the only one on Mars, and she discovers this dead colonist who comes to her hab, and this sets things into motion, which involve a rather perilous journey across Jezero Crater. It should be familiar to you all by its association with the Perseverance rover, to investigate what turns out to be the mysterious Colony 2.
Oh.
She was Colony 1. So, okay, here's the setup. So, Dr. Jan Malbec, she's stranded on Mars, right? She's the last survivor of a failed colony, Colony 1, and she can't go back to Earth because she's a biohazard. So her future looks absolutely hopeless. She needs to find a cure for the germ that infected Colony 1 before she can return to Earth. And it's been a few years since the original landing, and Earth, for various reasons, economic reasons apparently, and political reasons, all kinds of things, have basically forgotten about her. So she thinks she's the only one on Mars, and a barely conscious stranger arrives in her airlock at the colony, which was announced to her by her robot companion, Gizmo, okay? And this barely alive stranger, his DNA matches a colonist that was presumed dead for years. So it's kind of chilling and thrilling at the same time in equal measure. And the question is, if he survived out there, who else might have survived? So The second colony, Colony 2, where the geneticists fled, it turns out, may hold the answer and may provide the cure. So by reaching it, that triggers a chain of events that were, I found, really unanticipated. That was part of the fun of reading this book. It just hits you from directions that at least I didn't see coming. So that was kind of neat. There's relentless action sequences across the perilous Martian terrain, and that keeps the pace rather breathless from start to finish, I found. So it really kept me going. I didn't want to put the book down, so I would read it late at night and that kind of thing. So I love books like that. Major themes, isolation and the human spirit. And here's a quote from the book. Sometimes being alone felt like being buried under the weight of Mars itself. So when we think about going to Mars, we think about the technological problems, we think about physical survivability from the radiation and so forth. But we don't often talk about what it's like to be isolated on a planet many light minutes away. The emotional stakes then can run quite deep as the physical danger. And NASA's aware of this, by the way. And so they're including this in their long-term plans. In addition, human nature is a real threat. Colonization isn't just about surviving the environment. These are people. So there's greed, there's secrecy, there's ambition, and they're all there, and they're all dangerous forces on Mars. And then there's genetic ethics. Okay, so that genetics finds its way into the story in very interesting ways. Colony 2's whole premise revolves around genetic modification and cloning of people, raising some really unsettling questions about what humanity is and what it's willing to do to survive. So that was really, it was quite thought-provoking, I thought. Whoops, I went too far. There we go. Okay, so it's science fiction, but what about science accuracy? I found Colony 2 Mars occupies a firm but also flexible tier of hard science fiction. Kilby anchors the narrative in real-world aerospace engineering and planetary science, but, of course it's science fiction, stretches the boundaries of biotechnology and physics to drive the high-stakes, clone-centric thriller plot. How can any of you walk away from Space Oddities tonight or today and not buy this book? I can't imagine. So let's look at a few of these. Orbital mechanics and transit logistics. The transport technology used by the Interplanetary Space Agency is heavily modeled on modern concepts of SpaceX Starship architecture. The author, Kilby, pretty accurately reflects that reaching Mars requires multiple orbit refuelings in Earth orbit and relies on in situ resource utilization to process Mars carbon dioxide and water into methane, fuel for returning to Earth, as well as oxygen to breathe. That's all pretty sound. The geography and the setting. The book is set in and around Jezero Crater, which you know from the Perseverance lander. It also refers to Isidis Planatia, and that's the larger basin and flat plain where Jezero Crater is geographically situated. It accurately depicts the freezing temperatures on Mars, the oppressive dust, the low gravity challenge. I think they refer to it as 1/3 G. It's actually 0.38, pretty close. And as we are saying, the profound sensory isolation of living inside a sealed, pressurized environment. It touches on the toxicity of the Martian soil as well, but does not explicitly mention the perchlorates. Okay. How about radiation? Colony 2 Mars does deal with the cosmic ray hazard. Without a protective magnetosphere and with its weak atmosphere, cosmic rays on Mars can penetrate 1.5 to 2 meters into the Martian soil before dropping to levels that would be considered safe for organic molecules. The book deals with this in two ways. First, burying habitats under thick layers of Martian regolith, and then also the use of advanced materials such as Kevlar and polyethylene to absorb radiation where soil is not possible or practical, such as, for example, the rovers or specialized modules. So that's all pretty sound stuff, and I appreciated the science accuracy in those areas. There's a closed loop life support, the depiction of the main colony's biodome. This isn't it. Of course, there are no pictures in the book. But, utilizing specialized water recycling loops, artificial sun tracking spectrums, right? These are specialized agricultural lighting systems that are engineered to mimic natural Earth daylight within Martian biodomes and hydroponic facilities, and the hydroponic aquaponic food systems. I think these align very closely with experimental data gathered from real-world experience with Biosphere 2, as well as ISS life support structures. So all of that was pretty believable, I thought. This is a little more speculative, but let's call it extrapolated science. The biohazard protocol. The plot kicks off with Jan Malbec. She's stranded, right? She's a biohazard. While the exact nature of the pathogens discovered is tailored for fiction, the strict adherence to planetary protection guidelines is both legally and scientifically accurate. NASA and COSPAR, the Committee on Space Research, maintain rigorous protocols to prevent forward contamination, bringing Earth bugs to Mars, and backward contamination, bringing Mars bugs to Earth. So that was all pretty realistic. But there's this EM drive. Kilby explicitly introduces the EM drive, the electromagnetic drive, into his universe of propulsion systems. Now, in the real world, the EM drive was a highly controversial experimental thruster tested by NASA in 2013 to 2016 at Johnson Space Center, I believe, as well as other labs. It supposedly, so get this, it supposedly produced thrust by bouncing microwaves inside a closed tapered cavity. And while it appears to violate Newton's third law, generating thrust without propellant, it's been largely debunked by recent highly precise physics peer reviews. So Kilby utilizes this real world fringe experimental status pretty well as a sci-fi plot device, but of course deviates from actual science by its use. So how about advanced robotics? So I mentioned that her only, in Colony 1, her only comrade was a robot named Gizmo, which I think travels on wheels. So while the AI and robotics depicted manage entire automated mining facilities independently, current engineering dictates that communication latency between Earth and Mars, somewhere between 3 and 22 minutes, would require autonomous decision-making loops much more complex than what we can achieve today. The near sentient behavioral adaptations of the colony's robot veer slightly into classic sci-fi tropes rather than rigid computer science. But given the rapid acceleration of robotics and AI today, I think this is a fair extrapolation. There's also rapid DNA sequencing and cloning constraints. Without spoiling the major twists, the core mystery involves DNA testing and genetic modification anomalies. The speed, the accuracy and autonomy with which the colony's automated medical bays sequence, compare, and manipulate complex genomes, especially considering the devastating impacts of galactic cosmic radiation, right, on cellular replications on Mars. This glosses over the massive biological degradation that real-world space radiation would cause to DNA. So stretching a bit there. Ultimately, I thought the book delivered a narrative where physics of survival are realistic, but the biotechnology and propulsion mechanics are a bit bent, just enough to allow for an entertaining sci-fi thriller. So look, if you're a sci-fi fan who loves fast-paced thrillers, survival stories, and plot twists that keep you up past midnight, this book and perhaps its series might be for you. And I'll end there.
Oh, thank you, Lou.
Yeah, that was fun. I really enjoyed that.
Yeah.
Oh, and to our audience, if you like this kind of thing, sci-fi book reviews, or any book reviews, I suppose, perhaps, let us know, and maybe we'll do another.
That's good.
Andy, I can't hear you.
You're muted.
But we can't hear you.
So, right, it's working again now. I take it the book is available from Amazon and all good booksellers.
I believe so. Yeah. That's where I got it.
Can you give us the title and the author again?
The title is Colony to Mars, and the author is Gerald M. as in Mary Kilby, Kilby. Colony to Mars, part of the sequence of Colony 1, Colony 2, and Colony 3 Mars.
Thank you. Thank you very much. And Ian says, great review, Lou. Few spoilers. Thanks. Shame it's not a picture book, though. There you are. Book reviews are a great idea. More, please. Thank you, Ian. Thank you for that.
Okay.
What's he want? A pop-up book?
Yeah. Any other comments, viewers? Anybody want some more book reviews? Because it's something we can put together, obviously, quite easily. We're all avid readers, so we get through a lot of books between us. And what I'm just reading at the moment, I might talk about that next week. So there we are. All right then. So just before we go any further, a quick word from our sponsor. This video is sponsored by Picastro. It's like Instagram for space nerds. And a big thank you to Tom McCrory, who couldn't be with us this evening, for sponsoring Space Oddities, as always. If you would like to help us out by supporting the channel and enabling us to carry on bringing you the type of science we love bringing you, the first thing you could consider doing is buying us a coffee. You can scan the QR code here or click the link that should have just appeared in the chat, and that will take you to the Space Oddities buy us a coffee page, where you can keep our caffeine levels topped up for extreme.
That'll be important when you're reading Colony to Mars late at night and you want to stay awake.
Absolutely.
Which we will all do.
We all know what it's like getting older. That whereas, well, personally, I used to go to bed and I could read for hours before falling asleep. Now it's into bed, 2 pages, and that's it, lights out. So
no idea what you're talking about, Andy.
No. You can, of course, as well buy the Space Oddities t-shirts. Great for this type of weather. Long may it continue. And again, you can scan the QR code or click the link in the chat to go and buy a lovely Space Oddities t-shirt for a mere £20, including UK postage and packing. Good quality stuff. And also we have the hoodies available as well for when eventually the winter does decide to set in, and these start at £40, including UK postage and packing. If you're outside the UK, please add £10 to the total value of your order. You can also make a donation directly to Space Oddities by clicking the super chat icon underneath the chat window. It's the one with the $sign on, and that will allow you to make a donation to us directly. And as we always say, because we have to, every last penny goes towards keeping the channel going and paying the bills that we have to pay. So your support, as ever, is truly much appreciated, because we couldn't do it without your help. So there we are. Okay, right. So we're going to move on now, and we had some sad news this week, which Daz is going to tell us about.
Okay. Right, it's with a heavy heart that I had to announce that the Wally Funk, one of the original Gemini 13 women astronauts, test astronauts, has passed away. And of course, she made the news a few years back by being the oldest person to actually launch into space when she was aged 82. She died, unfortunately, a week ago, approximately a week ago, and she was aged 87. So I just thought I'd just introduce this this brief. Let's get rid of me close thing. This brief tribute to Wally. Oh, sorry.
Okay. Thank you.
Hang on, just bear with me a second. I'm in the right. Here we go. I'm doing Michael.
Yeah.
Here we go. There we go. Right. So right. Funk, known for her optimism and tenacity in the face of gender discrimination, gained worldwide attention in 2021 when she flew aboard Blue Origin's New Shepard rocket, fueling her lifelong dream of space travel. At the age of 82, she finally reached space on Blue Origin's NS-16 mission, becoming the oldest woman to do so. The flight lasted just over 10 minutes, but her spirit and enthusiasm made her stand out on the crew. In her last post-flight remarks, she expressed her deep passion for exploration and eagerness to fly again. She was one of the 13 women who participated in the Mercury 13 program in the 1960s, which aimed to evaluate female pilots as potential astronauts, but was ultimately sidelined due to gender biases. Despite not being selected to fly in space, Wally forged a path in aviation, becoming the first female civilian flight instructor at Fort Sill, the first female FAA inspector, and an air safety investigator. Tributes poured in after Wally's death, highlighting her determination and inspirational journey, which continues to motivate future generations, especially young women in STEM fields. Funk's legacy lies in her groundbreaking achievements and her role as a symbol of perseverance in aviation and space exploration. Godspeed, Wally Funk.
Thank you very much, Daz. It's worth noting that she was one of the original female astronauts selected. But then, of course, what happened was that NASA decided to can the whole female astronaut program. So although she trained and she was a fully qualified astronaut, she never actually got to fly until 2021. And very, very sad. So
because when the actual, how can I put this? The Gemini 13 wasn't an actual official NASA project, although they did. The ladies did train along the astronauts and all that. It was actually run by a person called Dr. Lovelace, and they went through all the same rigorous training as the male astronauts. And Wally was specifically when it was all I think it was Eisenhower who decided to scrap the scheme. They basically when they went through it, Wally was actually picked out as actually being better than a lot of the men. Also, she had such tenacity, such strength, and it was such a determined person that she matched and went beyond what some of the men could achieve. It was a very sad state of affairs. Again, it was all politically based and on a gender basis. So it was very sad that she went. Up until her last trip out, she was very vibrant, full of life. And it's just a shame that suddenly realised that somebody like Wally no longer exists in this world. It's such a shame.
It is very sad, but at least she achieved her dream eventually.
Exactly.
Better late than never, I suppose. But she was, I remember the conversations with her when she got back to Earth, and she was so absolutely thrilled about the whole thing. And but there we are. So rest in peace, Wally Funk. All right, we're going to go over to Uncle Dave now for his weekly look at times gone by. So Dave, take it away.
Okay. Thanks. Let's see. It should be up. Do you need to? Yeah, there we go. Okay. All right. So I'm sorry I missed last week, so I'm gonna cram 2 weeks in space exploration for this week, July 5th through July 18th. If you remember, 2 weeks ago, I just gave you a little preview, and I'll be going through all those. But actually, before I start any of those, let's go to just July 7th and July 12th, 1988. Launch of Phobos 1 and Phobos 2, the orbiter lander missions. They were sort of successful, I guess. Phobos 1 really was not. They lost contact September 2nd, 1989, before it got to Mars because of basically they uploaded faulty software. And it deactivated the thrusters, and it was just a big, dumb mistake. And once they deactivated the thrusters, of course, they lost the orientation. They couldn't contact it anymore, and it was lost. Phobos 2 did reach Mars. It did return data. It had a plan to go within 50 meters of the Martian moon Phobos and release these two little hoppers to the surface. But they lost contact with it just shortly before that, and so it never actually achieved that goal. But it was partially successful. At least it did return a lot of data from Mars. All right, starfish fry. Well, let me explain this one. It may not be obvious, but on July 8th, 1962. And remember that date because I'm going to tell you about it in a minute. But on July 8th, 1962, Starfish Prime, which was a high altitude nuclear test, the highest altitude nuclear test, one of the very few they did, and you'll find out why in a minute. They launched this from Johnson Island and blew it up, a 14 kiloton nuclear bomb above the Pacific Ocean. The picture there on the left is actually taken from Honolulu right around midnight, lit up the whole sky. But even more importantly, basically created a new radiation belt. And this radiation belt lasted for almost a week at a very high level of radiation. And in fact, what may be unexpected, maybe should have been expected, it took out a bunch of satellites. And there's the list of satellites that it damaged or destroyed. The track satellite was actually, they planned to have the track satellite in its orbit close enough to observe it, and it did, but it failed very soon after that. And you can see on the chart on the right there what happened. The solar cells were, they deteriorate as solar cells do at a very normal rate, and then Starfish Prime, boom, they just fell off the table. And so the satellites just failed soon after that. Transit 4B, the Ariel 1 it took out, Cosmos 5, Telstar 1, and Explorers. Anyway, you can see the list there. These are now at this time when this was launched, there were only about 100 satellites had actually been launched into Earth orbit at this time. So this thing took out about 10% of all the satellites that were ever launched. So yeah, not not the result I think they were hoping for. But in any case, it was yeah, it was quite a show, and they kind of stopped doing this stuff.
Because Ariel one, Dave, was a British built satellite launched by the Americans for us, so they immediately put that into the radiation belt. And then Telstar was launched a few days later, and of course that was the across the Atlantic TV satellite. And of course that got very badly degraded again by the radiation. So of course that failed not so long afterwards. So yeah, it was a bit of a of course nobody knew this would happen, did they? That was the thing.
I mean, yes and no, right? I mean, they didn't know this would happen because I don't think they would have done what they did, but they probably should have had an idea that something like this might have happened. I mean, one of the scientific objectives was to study the effect of an atomic nuclear blast on the radiation belts. So they had some idea that there was going to be an effect, but they did not expect it to inject so many energetic particles into the radiation belt in a semi-permanent way. In other words, they stayed there for days and days and really fried stuff. And I'll get to the Telstar actually in a minute. But
because the Ariel 1, although it was badly damaged, it did actually continue to produce a signal and data, and it lasted for decades, if I remember rightly, before it finally passed out. But sometimes it would just all come out goggly goop because of the damage that had happened to it.
I think all these satellites eventually succumbed to damage caused by this, but and many of them were debilitated for the rest of their times, and some of them worked fine. Especially because the solar cell damage was one of the worst things that happened to almost all the satellites. And they would just keep working. I mean, the solar cells were compromised, but they still worked up to a point, and then finally they just couldn't provide enough power to support the spacecraft anymore.
Because it's one of the problems now with the sun, the degradation of the solar panels. And of course, every time we get a solar storm, it degrades them that little bit faster. So it's something that they're concerned about even to this day.
Right. Okay, so let's see. Okay, that's okay. So yes, exporting American culture, such as it is. This is the Telstar. So you noticed notice the date, January 10th, 1962. Basically, it was effectively a day after the and maybe not wisely, but again, they didn't know what was going to happen. A day after the Starfish Prime, 2 days after Starfish Prime, they launched Telstar into orbit. And it was immediately exposed to this high radiation, this particle. It was damaged, and it did reduce its lifetime, but it did work. At least, at first it worked fine. It was the first commercial satellite ever launched. It made the first transatlantic transmission of a television signal. It had the first. Well, they did tests of radio communications across the Atlantic Ocean. It was quite something. I mean, now of course we take all that for granted, but at the time this was just revolutionary. The picture there, the sort of second picture on the left there is Vice President at the time, Lyndon Johnson, watching a broadcast from France, the very first full television broadcast made across the Atlantic Ocean, and then we succeeded, of course, the United States in transmitting our culture over to Europe, which I know you're eternally grateful for to this day. And but anyway, and President Kennedy made a speech shortly after that. And he started out a speech saying, "This is the first speech transmitted across the ocean and all that." So anyway, quite achievement. Definitely led the way to our current worldwide telecommunications.
Yeah, because you gave us the Fonz.
Well, I know, and I mean, all the you got to get I Love Lucy and Laughing, right? All the great American culture. So, so you're welcome. All right, almost everyone loves Jupiter. All right, well, so lots of stuff. July 6, 1938, Jupiter's moon Lysithea was imaged telescopically, and it led to its discovery a month later by Seth Nicholson going through the telescopic images and finding things that were moving, of course. July 15th, 1972, Pioneer 10 entered the asteroid belt on its way to becoming the first spacecraft to pass through the belt before heading to Jupiter. It was on its way to Jupiter. This was actually a big deal because at the time, they didn't really know what to expect in the asteroid belt. I mean, they knew that the asteroid belt itself was not full of asteroids, like going to be back and forth and pummeling the thing, and it was going to be dodging its way through like I don't know, whatever science fiction that movie. Oh yes, right. Every science fiction movie ever made that shows the asteroid belt, basically. But but they did not know. So they did know that it was sparsely populated with large bodies. But they didn't really know what the dust environment would be like. They didn't know if this thing would be just, hitting dust particles, all the way, and it's moving fast. So dust particles are very dangerous, even small ones. Turns out it was not a dangerous place to be. It wasn't. They didn't have any major problems going through the asteroid belt, and that was a paved the way again for all the other outer solar system missions, which pretty much have to pass through the asteroid belt. July 9th, 1979. So we're probably all remembering this. Voyager 2 flies by Jupiter, 650,000 kilometers from the cloud tops. And there's one of the, this iconic kind of picture of the red spot taken by Voyager 2, which is just absolutely still amazing, just amazing picture to me. And okay, anyway. July 13th, 1995, the Galileo probe was released from the Galileo spacecraft and 6 months later actually entered Jupiter's atmosphere. So Jupiter getting a lot of attention. And like I said, everyone loves Jupiter, but I said almost everyone loves Jupiter. And somebody didn't like Jupiter as much. July 16th, 1994, first fragment of comet Shoemaker-Levy 9. So, yeah, somebody had it out for Jupiter. Left lots of scars, gave it a bunch of black eyes. But this was amazing. This was an amazing event. Not only just sort of, astronomically and geophysically, I suppose, an event of this thing blasting into Jupiter's atmosphere and just giving us tons of information about the atmosphere, and also basically resetting our mindset about sort of comets and asteroids and the power and the probability of collisions with them. But also, this was right at the beginning of the World Wide Web, basically, and this was the first scientific sort of event that kind of broke the internet. And so astronomical observatories all over the world were watching this and posting their images, and everyone was going to these websites from all these astronomical observatories and really shut it down. We were doing that at Goddard and basically really crushed the Goddard internet for about a week while this was going on. But it was very exciting, and of course, again, it was like sort of everyone was speculating what would happen when this thing finally hit, because of course they knew far in advance because it hit, and then when it hit, it was like it sort of exceeded everyone's expectations, and it was great fun. Anyway, last call.
Go ahead. I point out that one of the great scientific opportunities here was that the pieces of Shoemaker-Levy were going to dive deep into the atmosphere and then produce a backwash that would come up.
Right.
So it's actually the opportunity to explore the deeper atmosphere of Jupiter.
Yeah, and they took advantage of it. They had, like I said, every observatory basically on Earth and Hubble and anything else in space was watching this, and they could time. They knew exactly when each impact was going to occur and where it was going to occur because they'd already mapped out the comet fragments. So it was, it was scientifically and sort of culturally just a great event. Last call. All right. Well, ESA Philae lander made its final transmission on July 9th, 2015. So yeah, rest in peace. It tried to land. It bounced across the surface a bunch of times. It ended up nestled under a under a rock in sort of a little cave on the comet nucleus. 67P Churyumov-Gerasimenko. I'm not probably hatcheting that to death, but anyway, we always call it 67P CG. So. But in any case, it did actually, they found it. It did transmit for a while, even though it didn't, land on a surface where it was getting enough sunlight to keep it going all the time. But every once in a while, it'd get a little sunlight in its little crevasse there, and it was able to transmit. But the final transmission came on July 9th. So 11 years ago, right? That's
yeah, God,
boy, that's
wow.
Yeah.
Can't believe that.
It is hard to believe. That seems so recent to me too. Well, and July 10th, sticking with ESA here, 1992, Giotto encountered comet Grigg Skellerup within 200 kilometers of the nucleus. It couldn't take any pictures because it had already gone past comet Halley and been damaged, and so it didn't have all its instruments working properly, but it still did return some data, and this picture is from the picture of the comet nucleus is from I don't remember. All right, it was well anyway, it was an Earth-based observatory that took that picture of the comet nucleus, but not Giotto, but it still did return information, and it's made good use of his instruments at Comet Halley, and got great pictures from Comet Halley, even if it couldn't get Grigg Skellerup. Okay, let's see here. Bilab. You probably guessed this one, but July 11th, 1979. Yeah, that was an easy one. All right. Skylab re-entered the Earth's atmosphere. And, I remember this really well. I was, working in a warehouse that summer off from school. And I brought a little map from the newspaper that showed where it was going to be at each orbit at a given time. And I was showing all my coworkers when it was going to be sort of overhead for us. And had a lot of fun with that. I knew friends who wore hard hats as a joke and things like that. But anyway, it was supposed to be, they really had planned to try to boost it again using the shuttle, but the shuttle was behind schedule and they didn't have it finished in time. So they just had to let Skylab go. Landed in Australia. Australia charged the United States $400 for littering, which actually eventually was paid off by a U.S. radio station, kind of as a gag, with one of those big giant checks, which the Australians posted on a on a billboard or something. But anyway, yeah, that's showing one of the oxygen tanks. So some of the big chunks did survive, and so just as well it landed in the Indian Ocean and in sort of the Australian, not the outback, I suppose, but I don't know what. Anyway, the Australian, unpopulated area. So it didn't. No one got injured by this, but one of those things that could have been. And I think this was one of the things that led people to try to be a little more careful about deorbiting large things in space. Okay, so. July 14th, 1965, Mariner 4 becomes the first spacecraft to fly by Mars. Transmitting pictures of data. I'm not going to talk a lot about it. It was a quick flyby, but it did get a lot of pictures. You can see on the map, it took a whole section of Mars and got little pictures of it. Pretty good pictures, considering 1965, considering the technology. The one on the left there is the very first picture it took. And they could pick out clouds. They could pick out some features. The highest resolution one that it took is on the right there, and obviously big cratered terrain and stuff. The funny thing was that when it flew by, the path it took happened to fly over a lot of the older cratered areas on Mars, and did not cover the Tharsis Bulge or a lot of the other areas. So the initial idea that came after Mariner 4 flew by and returned the pictures was that Mars was a lot like the moon. And it was only the later Mariners that showed that no, it really wasn't. It had all sorts of non-crater stuff on it. But at the time, it just happened that it took a path that showed very highly cratered terrains.
Right, but it changed the entire direction of the thinking about life on Mars.
Mm.
Yeah.
Right. I mean,
yeah.
There were possibilities for canals, all this stuff.
Right. With the later missions too, they saw these dendritic channels and all sorts of stuff that looked like, wow, this looks like water and rivers and earth and stuff. So it really, it was just interesting, that just the serendipity of they kind of missed all that with this very first flyby. It was the planet we started. You probably guessed this one too. We talked about this already, right? Okay, New Horizons. When it launched, Pluto was a planet. By the time it got there, it wasn't. But it did. Today, right? 11 years ago. Today, it became the first spacecraft to fly by Pluto. So.
Wow.
Yeah, they've just brought it out of hibernation as well, haven't they?
Yes.
Oh yeah, I just read that, right? Yeah.
It's been in hibernation for a year. Incidentally, Dave, you'll see it on Messenger, but I found a screenshot just serendipitously this week.
I saw that
of the countdown clock getting to 0000, indicating the closest approach to Pluto. So I took a screenshot at that exact second as a record of the moment that Pluto, that New Horizons was closest to Pluto. So
I saw that. That was really cool. I would have, if I had the time, I probably would have grabbed it. And I would have stuck it up there. Hey, if you want to show it, go for it.
I mean, it was an amazing encounter.
Yes.
And still providing amazing science as well, of course. But it tinged with sadness because we knew we'd never see it again in our lifetime.
True.
So there you
are.
No. Yeah.
Well, let's not talk like that. All right.
No. We've got lots of great stuff to come.
That's right.
All eyes forward
to It's not even a planet.
Why are we to Dragonfly now?
Why are we worried about it? It's not even a planet. Okay. Anyway, July 16, 2011. 15 years coming up. Dawn went into orbit around Vesta. So this is the first spacecraft ever to orbit a main belt asteroid, and of course, it went on to Ceres. So it really, basically our deep dive look into two of the biggest and most interesting bodies in the solar. I mean, asteroid bodies in the solar system. And so this was quite a mission. And of course, Vesta again. Was a surprising object, and the picture up there in the upper right there, you can see those grooves on it and everything. So they kind of built up a whole history of what happened to Vesta. But again, 15 years ago, that was we saw.
Because Dawn used ion engines.
Yeah,
and
that's right.
For a while, it was the as of course that everything starts off slowly, but the speed builds up, and for a while it was actually the fastest man-made object in space for a while. Because it gained such acceleration.
Yeah.
Absolutely. Okay. Oh, interesting. Okay, I did not know that. All right, thanks. All right, go back to 1931, July 18th. This is the very first rocket society that was formed in the USSR. The Grupa Izuchenaya Reaktivnogo Dvizhnenia.
Very good. That's
I would have stuck with GERD.
That may or may not be very good, but it was like GERD. It was first founded. Some of the luminaries that is Sergei Korolev. If you can see my pointer, anyway, in the very middle of the screen, and that's Friedrich Zander, who was really the father of on the there you go on the right there, was the father of really the modern Soviet rocketry. I mean, he's the one who really started them down the path to their whole space program. But he was the chairman. He was the founder and the chairman of the very first of GERD, of the very first. The building still stands where they used to meet. They used to meet in the basement of this building, in the picture in the center there. And there's some models at the Moscow Museum, I think it is, of a couple of their very first rockets that they designed. And I believe that is it. Yes, it is. Okay. Thanks.
Oh, thanks,
Thank you very much, Dave. That's absolutely brilliant. Yes, another trip down memory lane, courtesy of Dave. We all enjoy those very much, as I'm sure you do, viewers. Deep Burrito, thank you so much for your generous donation, sir. That's very kind of you, as always. Much appreciated. Straight into the coffers to prepare for the inevitable bills that we will have coming in. So thank you very, very much indeed. Much appreciated. You're very kind. Okay, right. We're going to go back to Daz now. Last week we were talking about the Tunguska event, and Daz just got an interesting follow-up to that, I believe.
Yeah, I certainly have. It was very strange that, like I said, last week we were talking about this, and more about this is more to do with the fact, if you remember, we said that part of the reason that a crater was not left, other than the fact that the meteor didn't reach the ground to become a meteorite, is that it was an airburst, and of course, most of the energy was dissipated in the air, which actually then encircled or then navigated its way around the Earth a couple of times, and it was measured using a barometer or whatever it was called. So anyway, this popped up this week, and this picture, the first slide you're looking at, as you can see, it's actually, and you'll find out why this picture's up there. It says a full view of the smoke trail of the Chelyabinsk fireball, and the reason for this is in a remarkable event last spring, a fireball illuminated the Alaskan sky, but conventional detection methods like satellites and cameras failed to capture it. Scientists led by Sandia National Laboratories turned to the sound generated by the fireball, specifically the infrasound shockwave it produced as it entered the atmosphere. Now, of course, infrasound human ears cannot pick up. This low-frequency sound could be detected over vast distances, as some energy also penetrated the ground, registering in seismic monitoring stations typically used for volcanic activity. This is one of the seismic monitoring stations, and I said earlier to the chaps, I said, this basically looks like a petrol pump, an old-style petrol pump. And what you've basically says the network of seismic monitoring stations like this one, more commonly used to track volcanic activity such as magma movement beneath Vesuvius, can also pick up the faint ground vibrations left behind by a fireball breaking apart high in the atmosphere. A research assistant, Logan Scampfer, noticed a distinctive N-shaped wave pattern in the seismic data, which indicated the presence of a fireball. Alongside physicist Elizabeth Silber, Scampfer utilized 57 infrasound and seismic sensors extending 360 miles from the event to reconstruct the fireball's flight path and identify its likely breaking up point. Their finds were corroborated by public dashcam and security footage revealing the object's shallow entry angle around 19 degrees and astonishing speed of between 50 to 56,000 miles per hour. Now, this is the seismograph trace that you were seeing, and this is where they found the N trace. It says a real this is, like I said, a real seismogram graph that you're showing up, showing the kind of traces scientists study every day. Buried in the charts, just like this one, scientists spotted the unusual N-shaped spike, the signature of a decaying shockwave from the Alaska fireball, hiding among the ordinary earthquake data. The analysis demonstrated that the fireball released energy equivalent to 38 tons of TNT and likely originated from the main asteroid belt. This search marks the first successful use of infrasound and ground vibrations to locate debris falls without visual confirmation, showcasing a novel approach for future meteor tracking when traditional methods fail. And thank you. That's it. Thank you.
Right. Thank you very much. That's great. So
it just seems strange that with this come along just after we've been talking about it.
And there you go. So luckily it was over Alaska. I mean, 38 tons of TNT detonating over a city could have been disastrous. But
it just goes to show how from the Tunguska event that we've now been able to develop and look at these new ways of detecting things that people in obsolete in areas where there's no populations, and it could happen over oceans and things like that. But now we've got a way of actually finding and possibly predicting where they actually fell. It's fantastic.
Yeah, fantastic. Thank you, Daz. Really interesting. Okay, it's over to Uncle Roger now for our weekly look at the night sky and the viewers gallery. So take it away, Roger.
Okay, and we do have a good gallery again this week. Thank you all for those that regularly post a picture. So thank you. And here we go for a week in the night sky. Okay, here we go for the first slide coming up. Okay, so what's in the night sky for the 14th to the 20th of July?
Oh,
well, what have we got? Okay, so we're just coming out of a new moon, a new moon, and working our way through to first quarter through the next week. And looking up at the night sky at midnight, we do not see any planets, but we do have the Milky Way going practically directly overhead with the summer triangle of Vega, Altair, and Deneb demonstrating the brightness of their stars. So there we go. And we've also starting to get Pegasus and Andromeda coming out through. So the Andromeda galaxy coming out through nicely as well through the night. But we do have Jupiter, which is now getting a bit closer to the sun shortly after sunset, so becoming a bit of a difficult target anyway. But we do have later in the week a conjunction of Venus and a crescent moon. This will be in a few more days' time. And will be quite a good opportunity possibly to capture shortly after sunset. So a good photo opportunity for the gallery next week if anyone's got a clear sky for that. But during the wee hours of the morning through this week and the coming weeks, we do have Saturn coming up nicely. Obviously with the plane of the rings now around about the 9 degrees. So a good opportunity to capture some of those with the Cassini division and the rest there coming up through. And following not too long after, that's about 92 hours, 2 hours or so, we do have Mars coming out through in Taurus at the moment. So although it is quite a small object at the moment, in fact it's arc second size, not much different to Uranus, unfortunately. So it's, although it can be quite a bright object, it's a very small target, so you do need to use a very long focal length to get any sort of definition of details on there, unfortunately. But that will obviously be a bit better when we do get the next opposition. So as you can see here, this is what you can expect to see with the angle of the rings now becoming more apparent. So it is a good opportunity to have a look. Obviously one of the more popular planets to look visually. And we've got some meteor shower delta Aquariids coming out through, so it's starting to becoming more interesting, especially in my part of the world down in the south, with astronomical darkness now starting to appear gradually from this Friday. So things are starting to look a wee bit better now with the night skies, fortunately. But we do have the peak around the end of July, so have a look at that if you do get an opportunity. And then obviously we've got the Perseids coming out through, although it does say it's early signs, but Comet Swift-Tuttle is the one that is the instigator of this wonderful meteor shower, so have a look at that when we do get to that. And unfortunately, we don't have much activity at the moment, although these pictures were yesterday, although I've got the date for today. There's only a few sunspots at the moment and not much coronal activity, although there is a little bit right down on the South Pole area. So it's looking a little bit dreary at the moment. So whether we are starting to get the cycle, the maximum cycle seems to be possibly ending, we won't know, but there we go. So onwards with the interesting parts of the gallery that our members like to show off their talents. Okay, so what do we have? Well, we've got our usual suspect from Ireland, of Michael, with a few images of the sun. This one was taken on the 7th of July. And as you can see, there was some nice large solar activity then of active region 4482. And if we move on to another one that you did 2 days later, we can see how much we've got there. And consequently, we've got some other active areas that have appeared ahead of 4482. So consequently, it does look a bit out of sequence, but that's how it's calculated with the numbering of how they appear during the region. But wonderful pictures there. Thank you very much.
Well done.
Very nice.
Yes. And we've got a few from Daz here. First, yay! And why not? These are from his S30 or S50. Let's have a look.
S50.
It's from his S50. And here we are.
Nice.
Very nice.
Wow.
Yeah, that's the Eastern Veil Nebula.
Yes. Although we have got a little bit of it cropped off, unfortunately.
Yeah, I should have adjusted the actual framing, so that's my bad.
Yes.
Thanks for pointing that out, Rog. Thank you.
That's all right. Just how it works, unfortunately. But you've got lots of interesting twirls there of the nebulosity.
Yeah,
there, anyway.
The thing was, I mean, with my skies, I vary between sort of like Bortle 3 to Bortle 4, depending upon what the cloud's doing. And I tend to get, 9 times out of 10, I can't see anything. But the last few, sort of like the 4 or 5 nights, I've had some seeing where I've been able to see a lot of the brighter stars. And the last couple of nights, I've been able to, we've had virtually, not cloudless, but a lot more seeing, so I can actually see the Milky Way and all that now. Yes. But yeah, so this was probably on a Bortle 3.5 on that night. So yeah, we do get some things come through. But I just wanted to point out that this is the S50. And I think that I can't remember. Did I send you one for the S30 for the same target? I don't know. Let's move on. Let's move on. So we've also got M11, which is only taken 10 minutes of integration time. Yeah. And of course, this is sat right in the Milky Way. You've got this massive star field around it. It's a stunning picture. I just thought, because it's one of my favorites, because like you say, you've just got that stunning backdrop to it.
Yeah, you see a lot of interesting star colors there as well.
Yeah.
Lovely. Well done.
Well done, Daz.
Yes. But we don't stop there. We've got the Dumbbell Nebula, which he managed to get with 31 minutes on his S50.
Yeah. Again, this one I'm a bit annoyed about because the actual image, the blue parts are more vibrant. So this has got some of that's got lost in transforming this over to the thing. But yeah, it was again Balshall 3.5 same night, and it's just 31 minutes with using the Sea Star. So yeah, very good, very good. I mean, it has had some tweaking, but it's only tweaking that I can actually do on the phone. I've got no downloaded apps to tweak them, but a lot of the tweaking actually be done. You can do with the Sea Star, denoising it and enhance it a little bit. Then I take it into the phone and then just tweak it there in an ordinary Android app. So
done very well though. Well done.
Yeah, indeed.
And to cut his last image, we've got M101, the Pinwheel Galaxy. This one's been a bit more focused with 45 minutes of indication.
Oh, that's
nice.
That's nice.
Yeah, very nice. Dan.
You can see I only had on Alt as because it's sort of like cropped in the corners here. You can zoom in, but then you lose the information at the bottom. But you can see some of the sort of like cloudiness, how it's affecting it around the edges. I'm using the cursor, you can't see it, but yeah, you can see some of the haze around it, which is a thing. But yeah, I've had some good seeing, and like I said, I've been able to get out the last few nights, and it's been a clearer seeing. But from my perspective, is that you do what I do, Daz, with the S30. Yeah, Sandra. Oh, Sandra, you've also produced. I've seen on Facebook. So you've produced some lovely photographs. So get them up in the gallery, and because they are really good. Don't be shy.
Yeah. Yes.
Oh yeah. Thanks, Dad. I didn't notice that, Ian. You know something I don't.
Is there something you're not telling us here?
I was born in Scotland, but I wasn't.
Right. Okay.
It's all starting to make sense now.
So we've got a couple of images from Leon Corns. He's in Stourbridge. So do you know this person, Michael?
I do know this person. He's a member of our society.
I guess something must have happened for you to get somebody else to put something on the gallery. So this was at 3 o'clock in the morning on the 8th of July. And got some noctilucent clouds.
Oh,
yeah. Nice one.
Very
nice. He wasn't quite sure whether it was, so we had to sort of ask about, and he was told, yes, that's noctilucent clouds.
Yeah.
Cool.
Yeah, well done, Leon. Fantastic image.
And nice. We've also got another one which he took a picture of.
Oh, that's beautiful.
That's definitely nice. You can see it as well.
Wow.
And it's good to we're not in the war, because there'll be wardens shouting, "Put those bloody lights out!"
Yeah. Sandra says, thanks, Daz. I'll send them in for next week. I keep forgetting. There you are. We look forward to them, Sandra.
Yes, that'd be good. More than welcome. Right. Okay, so that's our gallery that we had this week. So a nice, interesting collection.
Yeah, thank you very much, Roger. That's great.
I'm going to say nothing from Roger.
As always. Thank you for sending the images. And if you haven't taken the plunge yet and you would like to share your images with us, attach them to an email, one per email, please, and email them to gallery@spaceoddities.space. And they'll appear here and on your own gallery on the Space Oddities website, which is spaceoddities.space, basically. So there we are. Please don't forget to like, subscribe, and comment, because it really, really does help us. And when YouTube looks at our videos and decides whether to recommend them to other people or not, if there are no comments on the videos, it says that must be a load of crap, not recommending that to anybody. So the comments are really important to us. So if you could just do us the favor, just leaving some sort of comment after the show on YouTube, that would be great, because it really does help our videos propagate. and we're very grateful. Thank you very much indeed. Okay, well, I think it's that time of the week again, so we're going to go over now to it's time for Space number 3.
Oh no!
Oh yeah.
I'll take a pee, Bob. I'll take a pee.
If you're not familiar with how this works, I will give you a number relating to something to do with space, and you have to say what the number represents. So let's go to the first one. And the first number is 1 trillion.
Oh.
Is it number of stars?
In what?
Something? 1 trillion stars.
Andromeda?
Could it be in the Milky Way?
No.
Number of survey images from the Vera Rubin?
No. No more guesses. Viewers, please put your guesses in the chat, as ever.
Number of
We have
dollars
perhaps
that
400
SpaceX
billion,
worth.
so I'm guessing Andromeda.
Okay, it is, in fact, not that.
Oh, I hope not.
We're off again.
We're off again.
Wow.
Okay, it is, in fact, the approximate number of stars required to match the luminosity of the most distant quasar yet identified by the Agena telescope.
Wow.
So basically, this is a quasar that has been seen by Euclid when it was 670 million years old, and it shines, or shone then, with the light of 1 trillion suns. So that's unbelievably bright. Not even your sunglasses would save you from that, I think.
That was our second guess, Andy.
Well, they're really, really good sunglasses.
Yeah. Okay, the next one, 80 microns.
Oh, that's small.
That sounds small.
Is it a wavelength?
No, funny enough.
Okay.
I'll give you a clue. It's a depth.
Depth.
80 microns. It's a depth. It's not
Can it
very
treat
far.
them?
It
Yeah.
relates to something I talked about earlier, if that's any help at all.
Is it a penetration depth?
Of what?
Okay, so yes. And radiation?
No, I'm going to have to tell you this. Remember I said earlier that they'd rotated the mirror assembly of the ELT for the first time.
Right.
Remember I said that it floats on a film
The depth of
oil?
the oil?
The
That's
oil
the depth?
is 80 microns thick, about the
Wow.
thickness of a human hair.
Wow.
Oh, gosh.
Wow.
Yeah. So you can push that structure, which currently weighs 360 tons and will eventually weigh 550 when everything is assembled, when the mirror's on it and everything else. At the moment, you can push it around with your finger because it's floating on a layer of oil the thickness of a human hair.
I'm wondering, with all that weight, if you took the weight off, what volume that oil would actually be? Because that would be with all that weight, it's got to be.
And also, how do they actually measure it?
Yeah.
Well, you have a little dipstick, a little tiny dipstick.
tiny dipstick.
Mm.
Yeah, absolutely. That's quite an engineering feat, isn't it?
It certainly is.
Yeah,
It
I'll
certainly
say
is.
I like Ian's response.
What was it?
Depth of the ocean on the-
Yeah, let me put that up there. Ian says it's the depth of the ocean. And it could well be, Ian, if there were neutron stars. But yes, it would be something approaching that, I'm sure. So there we are. Because don't forget, on a neutron star, even a millimeter is a mountain. So, there we are. Okay, your next number. Your next number is 36.
36. Lou, your IQ test results came back. That's great.
I've improved. I've been practicing.
36.
My age now.
Is it a number of satellites launched or?
It's funny you should say that. No.
Okay.
No, it's you're not too far away. 36. Let me get this up here. Is a Falcon 9 first stage booster completed its 36th launch and landing this week, establishing a new SpaceX rocket reuse record. Booster 1067 carried another 29 Starlinks into orbit on the 9th of July. So it's the 36th time it's flown, which is a new world record for a reusable rocket. So there we are.
Ooh.
Very sweet. Your next number, 39.
House.
Sandra says my age. We're not going to argue with you, Sandra. Notice we're not arguing.
So obviously it's got something to do. Is this again to do with rockets?
Yes, it is.
39. What's been up 39 times?
That is exactly the question to ask.
Exactly.
This is the record number of flights for a reusable spacecraft.
Oh, is it the Dragon in then? Is it
The what? Sorry.
the Dragons?
No.
Oh, not the SpaceX Dragons. No. Oh,
No.
reusable spacecrafts.
Any
A
ideas?
reusable spacecraft. Oh, it's not Blue Origins, is it?
Blue Origin?
Yeah,
Are you serious? They've only flown about 3 times, not 39.
No, I'm talking about the new, not the new Glenn, the new
Shepard. No, not anywhere near.
Okay.
No, you kick yourselves. It's the Space Shuttle Discovery.
Oh, okay.
Oh.
No,
Nice.
Wow.
that holds the records for the most number of flights, 39.
Oh, okay.
Ah.
All right.
I would have guessed a lot less than that. Okay.
Yeah, there we are. Obviously, there were lengthy refurbishment periods between the flights, but it did fly 39 times. Okay, your next number, which I think is maybe the last one, actually. I think this is the last one. 101,000.
Cycles in Beijing.
No. Dalmatians.
Trombones in the big parade? I don't know.
76, isn't it?
That's right.
Satellites in orbit around the Earth?
No.
None's in a nunnery.
Well, that's a good guess, though.
Yeah. Okay, I'll have to tell you this one. The approximate combined number of exoplanets NASA expects the Roman Space Telescope could discover.
Wow.
Nice.
Oh, so
Around
it's a guesstimate.
100,000. Yeah,
Yeah, it's pretty.
100,000 through transits and another 1,000 through microlensing.
With microlensing. Okay, that's
I didn't
be interesting.
expect microlensing would be that prolific. I thought it'd be much less than 1%.
Well, this is what NASA are saying. So,
Well, this is what they're finding with James Webb, isn't there? They're finding so many microlensed objects in the old universe, and they're being, the microlensing is quite prolific, actually.
But this is planet microlensing. It's this
yes, that's right.
physics, but it's
It's a very rare event.
Yeah.
So anyway, we shall wait and see whether their estimates are correct. But 101,000 new exoplanets.
wow.
It's going to be in a fantastic time if you're an exoplanetist.
Yeah, wow.
So there we are.
Excellent.
All right then. So that's your space numbers of the week. Thank you for your suggestions, viewers. As
Yeah,
always.
I really do like that because that makes us look really dumb.
Or more dumb.
There's a reason for
Dum.
Don't lower yourself to my IQ, Daz.
Oh, don't worry. I'll never reach that high.
there's a good reason why it makes you look dumb, Daz. Anyway, moving on. We're going to go
It's
over...
called the shallow end of the gene pool. I know.
Roger, please get us out of this madness by moving us on to Constellation of the Week.
Okay, so here we go.
Oh,
And-
pretty.
Right.
Oh, lovely.
Wish I'd
Right.
taken that.
One of yours, Roger?
It is one of mine, actually.
Ah,
And I know. So I'm doing Lyra, which is almost into Michael's territory of size of Constellation. There we go.
I thought we'd done that.
Too many stars, can't concentrate. Sorry.
All right. Okay, so obviously when we can see it is obviously currently, as it's part of the summer triangle, so it is available to see through October as well. So quite a nice little constellation to notify and see. So Lyra takes its name from the lyre, the stringed instrument of ancient Greece, and was crafted by Hermes and gifted to Apollo, gods of music and light. And then it was be passed on to the hands of Orpheus, becoming the instrument of the heart and one of most antiquity's most enduring and heartbreaking stories. And here we go, story. It's story time. Okay, Orpheus, son of Apollo and the muse Calliope, was the greatest musician the world has ever known. He was said to be so transcendently beautiful that it moved rivers to pause, rocks to weep, and wild animals to gather peacefully at his feet. Even the gods were not unmoved. Sounds like a clip from Snow White and the Seven Dwarfs. There we go.
Don't you love it when wild
Hi ho.
Hi ho, hi ho. And when his beloved Eurydice died, Orpheus descended into the underworld itself, using only his music to soften the hearts of Hades and Persephone.
Oh.
So once
Excuse me, let me get a tissue. I'm weeping.
Okay. So as it goes on, it gets more and more sad with the Eurydice dying and Orpheus descends into the underworld. Then we've got the death of Orpheus and all the rest of it. We've got 7 months of song with Orpheus wandering the earth, playing and singing his grief for 7 months. And then Apollo's gift to the sky. So Apollo gathers the fallen lyre and places it amongst the stars. So there we go. That's how we get to that constellation. So everyone obviously knows the Alpha Lyrae is Vega. Yep. It's the 5th brightest star, so quite a good one. It was also featured in the film Contact with Jodie Foster, if people watch that. And it sits at the top of the lyre, so it's quite interesting. It's due to precession, Vega will be Earth's North Star in roughly 14,000 years ago, and will feature again when we do its full rotation round. But
look forward to it.
Yes. So we'll have another opportunity soon. So we do have a double star here. So we've got Epsilon Lyra, which splits into 2, and then into 4 under a small telescope. So it's like a double. So as we like to call them. See what you say. So Vega is roughly 25 light years away. It's 2.1 times the solar mass and is 237 times more luminous. So there we go. So it's much more luminous compared to the sun's mass. So it's quite an interesting fact there. But we've got this image here of Sheliak and Selaphat, the constellation's living edges. So we've got an orbiting eclipsing binary star in a neutral orbit. So quite interesting. So it the variation in the luminosity varies every 12.9 days, and is some 620 light years distance. So can be quite an interesting observation if you're into variable stars. So obviously getting into what else Lyra does contain. And everyone obviously knows and has probably seen, hopefully, at some points, the Ring Nebula, M57, roughly 7,000 light years ago. This image is not mine, unfortunately, but we've also got another Messier object, M56, which is a globular cluster, which is nearly 33,000 light years away. And it's roughly 84 light years in diameter and 13 13 billion years of age. So it formed quite early on in the formation of the universe.
Yeah, indeed.
Well, there we go.
Globular clusters are really mysterious things that we don't really understand.
Yeah, but as I was saying earlier on, with Vega becoming a polar position, this is obviously due to the rotation, axial precession of the wobbling pole doing a circular part of the sky, and over the well, currently we've got roughly Polaris in its position, so it will move out of that way and move on to other stars in the direction that the Earth is wobbling around in. So what have we got in previous polar stars? Well, 3000 BC, it was Thuban in Draco. And then we've got Polaris, obviously, in today's time. So in AD 14,000, Vega will be back in its position as the polar star again. And then in another AD 26,000, it will be back again to Polaris again. So, but there will be other stars that will be in that position fairly close to that polar point. But there we go.
Okay.
Very good.
Thank you very much, Roger.
You were talking about the double-double. You're talking about, well, Fred. This is what Fred's double-double is.
Yeah. Not very healthy, but there we go.
Yeah, we are. Well, over at the Dallas Stadium, it's 4 minutes into injury time. Spain are leading France 2-0. It's the 4th minute of injury time after the 90 minutes. So I think we can more or less safely say that Spain are through to the next round.
Ooh.
Wow, that's the finals, right?
Next round. Finals, yep.
That will be, yes.
Oh, yeah, it will be, yeah. Where England will be joining them.
Possibly.
Anyway, just thought I'd tell you that, viewers, in case you were wanting to watch the World Cup, but you couldn't possibly because you wanted to watch Space Oddities much more. So, which is perfectly understandable. And we thank you all for not watching the World Cup tonight and for spending your time with us. It really is much appreciated. Next week, we're going to be doing a bit of a special because it's the anniversary of the Viking, 50th anniversary, in fact, of the landing of the Viking landers on Mars. So we'll be doing a special program all about Viking, and we'll be putting a few videos up to go with that on the channel. So do keep an eye out for those. And we hope to see you next week for a jolly old delve, as only we can, into those incredible spacecraft which touched down on the surface of Mars an unbelievable 50 years ago on the 20th, if I recall. Yeah, on the 20th. Yep. Right, it'll be 50 years during America's bicentennial year, of course, as we remember. And it was a fantastic summer for everything, really. And it was that fun in the UK. We had that fantastic summer where I was in Wales. We had no rain between May and September. It was an unbelievable summer, and it
all depends. I was working on a farm. It wasn't no fun.
Squeal, piggy, squeal. Yeah.
And I was only 15.
Oh
dear.
Yeah. And if
so you say, Michael. So you say.
Okay. Just before we go, we're into 7 minutes of injury time. Still Spain 2, France 0. So there we are. So we will bid you a good evening. Thank you so much for watching. We hope you enjoyed the show. Don't forget to put those comments in the on the video afterwards, please, because if you'd be so kind, it takes a second, but it really, really helps us. So there we are. All right then, guys. Thank you, viewers.